Okay, hi guys. So let's continue on discussion. Some more questions on the stopping potential and the photoelectric effect. Okay, so let's continue. So let's say if the threshold wavelength for producing photoelectric effect is 200 nanometer, so what would be the wavelength of radiation to produce photoelectrons having half the kinetic energy of those produced by radiation of lambda equals to 120 nanometer. Okay, so this is the threshold wavelength for producing photoelectrons. Okay, what would be the wavelength of radiation to produce photoelectrons having half the kinetic energy of those produced by wavelength of 120 nanometer. Okay, so let's see this. So we can write kinetic energy 1 would be hc by lambda 1 minus hc by lambda naught. This is hc by lambda naught. Okay, and kinetic energy 2 would be hc by lambda 2 minus hc by lambda naught. Okay, and we have to produce kinetic energy 2, which is half of kinetic energy 1. Okay, so kinetic energy 1 would be, you can easily calculate. Okay, so half of kinetic energy 1 would be hc by lambda 1 minus hc by lambda naught equals to hc by lambda 2 minus hc by lambda naught. Hc from all the terms will be getting cancelled. We would be having half 1 by lambda 1 minus half 1 by lambda 0 equals to 1 by lambda 2 minus 1 by lambda naught. Okay, you can rearrange the equation to suit it. So we need to find the value of lambda 2. Okay, so value of lambda 2 would be nothing but half of lambda naught plus lambda 1. Okay, so you can easily calculate this. Okay, next let's move on to seeing Bohr's atomic model. Okay, Bohr's atomic model. So this is based on the quantization of energy. Okay, and in simple terms we can put this as electrons revolve around outside the nucleus in definite circular paths. These circular paths are called orbits. Okay, so the first point we can write it that electron revolves around nucleus in definite circular path and these paths are called orbits. Okay, so orbits are nothing but stationary states, as electrons while moving neither gain nor lose energy, or delta E would be 0. electrons, rather it should be small e, electrons revolving neither gain nor lose energy. Okay, in simple terms, delta E would be 0. Okay, and energy of electron do not increase or decrease with time, so they are called stationary orbits. Okay, that's the reason why they are called stationary orbits. Now these orbits are called energy shells, where lowest shell is K shell, is n equals to 1, L shell where n equals to 2, M shell n equals to 3, and N shell n equals to 4. Okay, so just to illustrate this, we know that suppose this is a nucleus, these are all the orbits. Okay, so now what happens is these electrons revolve around or revolve in these orbits. Okay, so what will happen is, if we supply this energy to the electron, it will go and jump from lower orbital to, or from lower orbit to higher orbit. So energy supplied would be delta E equals to hc by lambda. Okay, and if this electron goes back again from higher orbit to lower orbit, then it would actually emit energy. So energy emitted would be again hc by lambda, or you can also have h nu, where nu is the frequency of photon. Okay, so with this we come to an end of this lecture. In the next lecture we'll be continuing on seeing Bohr's atomic model. So till then, good luck and goodbye.